Modern day AI revolution has become possible due to large language models such as GPT, Gemini, Claude, etc. In this video, we will understand 5-step process of how large language models are built. This video is useful to anyone who is generally curious or to a person who is preparing themselves for an AI research engineer role. To share some facts, OpenAI spent more than $100 million to train GPT-4, and that is only the compute cost. Similarly, Google spent $191 million to train Gemini Ultra. The very first step is data curation. These LLM models need humongous volume of data for training purpose. So obviously, the very first step in data curation will be data collection. For this, they use wide amount of data on internet, books, all the code on GitHub, Wikipedia articles. Okay, so they scrap the internet and they use it for training. Now, the scaling law of neural network says that as your data size increases, your taste loss will reduce, which means the performance of your model will improve. So these three charts tells you that, see here, as your data size is increasing, your taste loss is reducing. As your compute increases, your taste loss will reduce. As number of parameters increases in your model, your loss will reduce, improving the performance. So it is proven that as you build a big model, the accuracy and capability of the model will improve. This diagram shows the tokens which are used to train all these models. Look at GPT-5, 70 trillion tokens. Llama 4, 40 trillion tokens. They use this humongous data set to train the model so that they achieve even higher capabilities. And here on Hugging Face, you will find data sets such as FineWeb. So if you look at this data set, it has 25.9 billion rows. You see this size? So this type of data sets are used to train LLM. So let's say if you want to train LLM model, maybe you can go ahead and use this open source data set on Hugging Face. There are repositories such as Stanford Alpaca, which is a dataset of 52,000 instructions and demonstrations generated by OpenAI's text Da Vinci model. Now, if you have some background on machine learning, you will know that they follow the garbage in, garbage out approach. So while training the model, if you don't feed good quality of data, the model will not perform good, okay? Therefore, data collection is not the only important thing. After you collect the data, you need to do data cleaning and filtering. Now, when you scrap internet, see, it seems easy to say scrap internet, but on internet, how many websites are there? How much data is there, right? Humongous amount of data. And some of this data will be garbage. So you need to filter all that garbage data. Also, if you know NLP, there is this thing called text pre-processing. So let's say if you're scraping text, a web page, okay? So web page will have all these HTML tags, right? So it will have all these HTML text, div and so on. You need to remove all of that, okay? So that comes under data cleaning and filtering. You also remove all the garbage or the illegal websites, etc. And then comes deduplication. For example, if I'm searching for Apollo launch article, you will find tons of websites which will have same information, okay? So you need to do dedupe to remove those duplication. Now there are a couple of ways where you can remove duplicates. You can first check for exact duplicates, where you check using SHA-1 or MD5 algorithm, okay? And you just hash those documents. So when you are searching internet and all those articles, you can call it a document and you generate this SHA-1 or MD5 hash, and using that you can remove identical web pages. Then there can be near duplicates. So for this, use algorithms such as min hash, sim hash, locality sensitive hashing, LSH. Let's say 2 web pages which differs by small edits. Again, you don't want to use both the web pages to train your model. You can remove a duplicate there. And then there will be semantic duplicates. There could be 2 different ways of saying the same thing. So you want to remove the semantically matching duplicates as well. And then code deduplication. If you search for merge short code on internet, you will find thousands of articles. You don't need to feed all those articles. Okay, so you will remove the identical code logic which has different variable names, but the eventual goal of that code is similar. Okay, so these are the steps. Then also you do de-identification to remove personally identifiable information, any sensitive information, and so on. You also need high quality data set for something called fine tuning. So we'll go over fine tuning in a bit, but you need this for your model to follow instructions, generate valid JSON, and have normal conversation. And these data sets are generated via human annotations. Okay, so OpenAI, for example, use Canyon workers to make ChatGPT less toxic. So that's where the safety filter comes in. If you want to have your LLM do a very domain specific expert like conversation, then what these guys will do is they will have human experts. Let's say you want to make your GPT model good in legal conversation, then they will hire legal experts, lawyers, etc., to provide them this question and answer pairs with which they can fine tune. So we'll go into this fine tuning approach in a bit, but since we are talking about data curation, I want to make sure this is captured, that you need this kind of curated question and answer pairs for fine tuning. And there are companies like Scale.com is a company that these companies like Meta, Gemini, big companies which are building LLMs, they will use Scale, and Scale will provide you that data set, those curated solution that you need in order to build LLM. By the way, Scale is acquired by Meta, and the CEO of this company is a very young guy. He's, I think, Meta's AI chief or something, and Yan LeCun is in his team. Second step in the process is tokenization. Computers do not understand text. Okay, computer understands only numbers. So before you train your model, you need to tokenize your text. So let's say I have this statement, I am eating paratha. When I'm training my model, I will tokenize it. And tokenize is loosely related to splitting a sentence into words. That's a very loose definition. But see, you can have tokens like eat and ing. They can be two different tokens. And these are the token IDs. And once you have split the sentence into tokens, you will create embeddings for each of these tokens. And if you want to learn embeddings, by the way, you will find tons of videos on my channel, on internet, etc. GPT uses something called byte pair encoding for creating these tokens. Okay, here I'm showing you one video where you can understand word embeddings in detail. Now, some modern designs will skip conventional token splits, and they will operate on raw bytes such as UTF-8. Okay, so that no language specific tokenizer is needed. Now, the third step after you have split your text into tokens is creating a model architecture. Okay, so just to summarize, so far what you did is you scrapped humongous amount of data on internet. And once again, it seems so easy to say that, but if you have worked in programming, you will understand it's a humongous task, folks. You need distributed computing. Okay, you need maybe Spark or something to process that kind of data. You need huge human workforce for creating those human labels, removing toxicity, and so on, right? So let's say you spend millions of dollars and you accomplish these two steps, data curation and tokenization. The third step now is model architecture. And you all know probably that transformer architecture is the backbone of a LLM. Okay, and here is a picture of transformer architecture. And it will take me probably 1 hour to explain this. So what I did is I created 1 hour long video going over transformer architecture in detail. Just in case if you're curious, we are going to provide you a link. At the heart of transformer architecture is attention mechanism. So what attention mechanism will do is, let's say you have two sentences and you have this word bank. Okay, it's a common word, but the meaning is different in these two sentences. And when you are generating contextual embedding, this attention mechanism will make this word attend to all these different words in a sentence. Okay, so the meaning of the word is determined by its company. So this bank in this sentence means the river bank. In this sentence means the bank where you go to withdraw your money. So this word will attend to all these different words, and the mechanism which makes that possible is called attention mechanism. And in my transformer video, I have explained there is a math behind it, but attention mechanism is the fundamental component of transformer architecture. And nowadays, there are different variants of attention mechanisms such as flash attention, sparse attention, and so on. And these variants have come up because you want to make your training process efficient. You can understand, right? These companies are spending millions of dollars. You need thousands of GPUs in a distributed data centers. And this training will take months actually. So you want to do every single optimization that is possible. And therefore, for attention, all these variants, flash, sparse, etc., the goal of these techniques is to achieve the efficiency and speed. Similarly, for position embeddings, you will use techniques such as a rope, okay? And by the way, attention, position embedding, all these are components of that transformer architecture. So if you have seen that video, you will understand it better. Then for scaling, you use something called mixture of experts, and mixture of experts is a technique that is being used in this DeepSeek. You know, when DeepSeek came out, for initially there was a buzz on the internet, US stock market crashed, etc. And they used this mixture of experts to achieve the efficiency and speed. Then when it comes to activation functions, if you have learned deep learning, you will know that there are traditional activation functions such as ReLU, sigmoid, etc. But nowadays, these techniques such as GELU, SWIGLU, all these new variants are created again to achieve efficiency and speed. And then you might be aware about optimizers such as ADAM in traditional deep learning. And nowadays, these new optimizers have come up such as Muon, just because you need scale and efficiency, okay? The fourth step is model training at scale. When you look at this diagram, you clearly see the huge amount of processing that you will require to train a model on these many tokens. 70 trillion tokens on GPT-5. Other than tokens, so tokens is basically your data size, right? Other than tokens, you also have huge number of parameters. So GPT-4, for example, has 1.76 trillion parameters that you need to tune. Now, just in case if you don't know what parameters are, this is a classical picture of a neural network, and they will have all these ages, right? So let's say they will have all this weight. So 0.12, let's say this is one weight, minus 0.76, this is another weight. So these weights on the edges are basically parameters. So this is first parameter, second parameter, and this diagram will have probably 100 parameters. Imagine a neural network having 1.76 trillion parameter. It's humongous. That's why what companies do is they have these huge data centers, and these data centers will have all these racks which will have GPUs, and they will do massively parallel processing, and they will do everything in their capacity to optimize the training process. In YouTube, you will find this video where OpenAI is building a mega factory in Texas, and it is part of their Stargate project. So Stargate project aims to build these massive data centers, and there are hundreds of millions of dollars which are being spent. Look at this facility in Texas. It's a huge facility. It will have thousands and thousands of GPUs inside it, which will power these factories. And Donald Trump and US administration announced this Stargate project in collaboration with OpenAI, SoftBank, and Oracle. You saw like Oracle CEO speaking, SoftBank. All these companies are collaborating to build these massive data centers, okay? And at the core of this data center, you know, what is the most important component in these data centers? Well, it's GPU. So what I have in my hand is Titan RTX GPU, and these GPUs are used to train the LLM models. And this is the reason NVIDIA stock has been rising. In last 5 years alone, the stock has grown like 10 times. So if you invested $1,000 5 years ago, it will be right now 10,000 or even 12,000, okay? So NVIDIA is a company that produces GPUs, And all these big companies which are training LLMs like OpenAI, Google, Meta, Amazon, they are buying NVIDIA's chips like crazy, okay? And it's not just training, folks, it's inference also. So they are building all these mega factories to train the model as well as to solve those AI workloads. And what these companies are doing is they're hiring performance engineers to optimize the use of every single transistor on these devices, okay? So all these companies will have special engineers who are having these skills in CUDA programming. By the way, CUDA is a C++ framework using which you can write GPU code, okay? So they will hire these C++ engineers so that every single transistor, every single capability on this GPU can be utilized at its best. Model training also has some sub-steps like pre-training, mid-training, supervised fine-tuning, preference fine-tuning, RL with verifiable rewards, etc. So let's go over these sub-steps in brief. So during pre-training, what you do is you train your model so that it can predict the next token. Now, what does it mean by predicting the next token? So if you're in Google, Gmail, and if you're typing any sentence, you will notice, see, we can do that. So when I type we can, it is completing this do that. So it is predicting the next token. So when you say sure we can, it is predicting this next token. Once do is predicted, it is predicting this next token. So the goal of pre-training is to have your model predict the next token. Now, if you look at ChatGPT, ChatGPT is not just predicting next token. It's a full-fledged question and answer kind of chatbot, okay? But in pre-training, you don't achieve a ChatGPT type of behavior. Here, you get your model to predict the next token, okay? So it will learn statistical regularities, all the statistical patterns, okay? So if I say, sure we can, then you are learning this probability that the next word is can, okay? Next word will not be, let's say, car. Have you seen a sentence on internet which says sure we car or sure we pizza? You know, so you understand. So if you look at all the text on internet, you will find some statistical patterns, okay? You will also acquire foundational linguistic structures like grammar, etc. And then you will develop abstract representation of world knowledge, okay? And once that stage is done, you will have mid-training. So here you will fine-tune the model's thinking patterns before it learns to follow instructions, okay? And following instructions is the next step, by the way. But in the mid-training, you will include long context documents or instruction-rich Q&A designed to improve memory coherence and strategic reasoning. Now comes interesting step, which is supervised fine-tuning. It is also known as instruction tuning. So here, you will give your model question and answer pair, and you will make it more like ChatGPT. See, in the pre-training, it is just completing next token. But here, you ask a question, it will generate the answer. It is sort of like, let's say you are preparing for an AI engineer role. So in the pre-training phase, you will study, okay? You will study all the material, etc. But in supervised fine-tuning, you will prepare for interview. So you will give mock interview where they're asking you question and you generate the answer. I hope with this you understand the difference between pre-training and supervised fine-tuning. And for this, there are many instruction data sets, okay? So if you look at this data set, this is alpaca cleaned and it has question and answer, see? So the question is, or the instruction is, give 3 tips for staying healthy. And the output is eat a balanced diet, whatever. What are the 3 primary colors, okay? So that is your question. And the 3 primary colors are red, blue, and yellow. Okay, so you will find, if you go to internet and if you search using this instruction fine-tuning tag, you will find variety of data sets. For example, bioinstruct. So if you look at any of these data sets, instruction, okay, identify the main conclusion from the provided medical report. And the output will be whatever, right? So these are the data sets which are available for free, by the way, on Hugging Face. Then comes preference fine-tuning. So in preference fine-tuning, you will align LLM's behavior with human values. Okay, you want to be safe, polite, and aligned with what users actually like. So here, reinforcement learning with human feedback comes in play. So you might have noticed that sometimes when ChatGPT generates answer, it will generate two answer, and it will say, okay, which answer you like the most, and you will say, okay, click, and ChatGPT will register that. Okay, so RLHF is one technique for doing this. The other one is direct preference optimization. Okay, we are not going to go over in detail, but you can Google about this technique, DPO. Now, there are a couple of issues with traditional RLHF, which is, okay, human judgments can be wrong or biased. It is not scalable. Okay, you can't have humans annotate like your billions of rows, and it's hard to verify whether the feedback is correct. Okay, that's when RL with verifiable rewards come in play. Okay, so it will try to address some of the shortcomings of RLHF. So here, verifiable rewards means rewards that can be computed automatically and unambiguously. So here is a step-by-step process of how it works. First, you define your task. Okay, choose a task with clear checkable goals. Let's say you are writing code. Okay, you want LLM to be trained on writing the code, and then model will produce multiple outputs. Okay, now each output will be scored by a verifier. So let's say if it has written a code, you will have a test suite. So you will run the test suite, you will run the compilation, and based on the result you will verify the reward, or based on the result you will apply reinforcement learning, where you will reward the model. So if all the tests are passing for your code, you will give a higher reward to your model. Okay, so you will use this reinforcement learning here for this particular technique. Okay, so this is a brief summary of these 5 steps, and at the end, the 5th step of LLM building process is evaluation. Okay, evaluation is basically you train your model, you want to know, is it actually good? Is it something, let's say you are working in OpenAI, you have trained GPT model, you want to figure out, is it something you can release it to ChatGPT as a backbone of ChatGPT? And for this, you need to verify if it is giving accurate answers, which means it is passing all those technical benchmarks, as well as you want to make sure it adheres to human values of helpfulness, safety, etc. Now, when you're testing these models, one problem is they generate different answers every time, right? So if you are working in traditional software coding, it is deterministic. So you can have exact test output and you can match. But here, it is generating different output all the time. It is probabilistic in nature. Therefore, one approach you can use here is, let's say this is your test suite. Okay, you have 3 test cases, test case 1, 2, and 3. And then for every query, you will have expected output. Okay, and let's say actual output generated is this. See, it will not match word to word, but you can use something called cosine similarity to find out the semantic matching. Okay, how does these 2 sentences match in terms of the meaning that they try to convey? So when you match it semantically, let's say if they are 95% match, then you can have some threshold. Let's say if they are more than 80% match, okay, pass the test. Then you also want to make sure that it is safe. So when someone say, okay, give me a technique to make a bomb at home, your expected output should be, sorry, I can't assist with that. Okay, actual output can be little different. It may not match word by word, but as long as the meaning wise they are similar, test will pass. Okay, then let's say you can have this sentence, which is, let's say actual output is not very much matching to expected output. In that case, the similarity, semantic similarity will be less and the test will fail. Okay, so this is one technique. There are variety of metrics that they use other than cosine similarity, like Blue Score. They use another models. There is teacher and student model, or LLM as a judge. So one LLM is producing answer, the other LLM is becoming a judge. And there are many technical benchmarks. So if you look at Gemini 2.5 release, you will see these benchmarks. See, you always see these benchmarks, right? Like AIME, then Live Code Bench, and so on. So these benchmarks will try to judge model on various aspects. For example, SWE bench will try to judge it on its code writing capability. Then massive multitask language understanding will be used for any academic and professional subjects for its knowledge and reasoning. Then there is this math benchmark, AIME, that will evaluate the model on the math performance. All right, so this is the summary of these 5 steps. I hope you learned something new out of this video. This is how they train the LLM. Now, training LLM is something that is evolving every day, right? These companies are spending millions of dollars in AI research. So new techniques are coming up. The exact nuances may vary, but this is an overall approach of training LLM. I hope you like this video. If you have any questions, please post in the comment box below. Thank you very much for watching.